In this video I will show you how you can create your own gripper. So let's create a station. Then you have to download the gripper from Sakai in the resources folder, and then we go to the import geometry here. Then browse for geometry. It's this one here, it's a .sat file, and open. For this gripper, the orientation of the origin is already right from the file itself, but maybe when you create another gripper, you have to adjust the origin as well. You can see how that is done in other videos, how to create libraries. Then we will create a frame from 3 points and from 3 points, and we will make the TCP1 first. So let's zoom here, 3 points, and we select this here. And now we want the x-axis to point downwards and the z-axis to point outwards. So this is the x-axis and this is the y-axis. Create. Okay, now we have to adjust the position. Let's measure how far these two are apart from each other. It's 0.3 millimeters, so we have to move the frame in the negative x direction by minus 0.15. Apply, and now it's in the middle. So the fingers, let's measure how wide the fingers are. They are 20 millimeters. So let's move the frame into the positive y direction by 20 millimeters. We choose local because we want to move in the coordinate system itself, and here 10 millimeters, and apply. So now the TCP1 is in the right place, and let's move on to the TCP2. I will hide this one here so it's easier to see, and put this as UCS. Okay, then create again a frame from 3 points, and in this case we want the z-axis to point in this direction and the x-axis to point down. So again, x-axis, and the y-axis, I don't think we can do that, so we have to rotate it later. So now we rotate around the x-axis for 90 degrees in this rotation. Okay, then we have to move it up again into the middle, so that's again minus 9.5 here. And now let's measure. Make sure you have activated the frame as a UCS. And now let's measure from here to here, and we can see it's minus 30 in the y direction. So we have to move the coordinate frame minus 30 in the y direction. Again, local minus 30. Apply. And now you can see here this is exactly where the x-axis should be, and this is 2 millimeters inward here, but we will measure it here. Now you can see it's 2 millimeters, so we move it into the z direction 2 millimeters. Okay, and go here again, and 2 millimeters here. So now also this is in the right position. And now we will move on with creating the TCPs. So go here to modeling and create tool, and we'll give it whatever name you want. And use existing, and this one here, the mass is approximately 0.4 kilograms. For the center of gravity, we can look at the drawing. You can download that one as well. And this one here. And here you can see the center of gravity. So it will be 135.75 millimeters in the Z direction and 29.63 in the X direction. So 29.63, I guess it was. Let's see again. Yes. And 133.75. This doesn't matter so much because the mass of the grippers are just 0.4 kilograms, but maybe if soon you use a heavier gripper, you have to pay attention to this. So now the frame 1 is the TCP1. Let's call it TCP1 here and move it here. And now TCP2 and frame 2 and move it also here. Now done. And we can delete the 2 frames here. And you can see the 2 TCPs right now. And now we can save this as a library. And let's save it with the right name and wherever you want. And now you have the gripper. So we will open a station now with the robot, and I will show you how you can mount it to the robot. Or let's do it in this station. From existing controller and the IRB120. Then choose any one of those. And the controller is started. And now go to import library, browse for library. And now we can see this is the one we created. And now it's here. And just by pulling it onto the robot, we can move it to the tool 0. And yes, we want to update the position. And now the robot has its own gripper.